Now that we've learned how to solve radical equations, we can apply that to solve different types of application problems. Most notably, we're going to look at how to solve problems that deal with the Pythagorean theorem. Now, the Pythagorean theorem was founded by the mathematician Pythagoras around 500 BC. But he said that in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. And the hypotenuse is the side opposite of the triangle. So if we look at our example of a right triangle down here, we have our 90-degree angle in the corner, given by the little box there. Well, that means that the hypotenuse is the side opposite of it. That's our C. And our legs would be the two sides adjacent to the right angle, so A and B. So his theory said that A squared, the first leg if you square it, and the second leg if you square it, will equal the length of the hypotenuse if we square it. So let's look at an example. Let's look at a proof of this. If you think about this right triangle with sides 3, 4, and 5, you can see that if you would take that and you'd plug 3 in for A, and you plug 4 in for B, since those are the two legs, and then you plug 5 in for C, since that's your hypotenuse. If you do the math, 3 squared plus 4 squared equals 5 squared, well then you get 9 plus 16 equals 25. And we know that that's true, because 25 equals 25. For those of us who can see this more visually, you can think of it this way. 3 squared is 9, so there are 9 boxes here. 4 squared is 16, so there are 16 boxes here. If you square 5, you should have 25 boxes. And that's actually what you have if you combine the yellow boxes with the orange boxes. So how can we use this? How does this connect with our radical equations? Let's look at an example. It says, find the length of the hypotenuse of the triangle shown. Well, if you look at our triangle, our right angle is right here, which means that our hypotenuse must be letter C. So we'll use the Pythagorean theorem. A squared plus B squared equals C squared. And A and B are our two legs. So it doesn't matter which leg you put in for A or B, but I know that 4 can go in for A, so 4 squared, and 5 will go in for B, so that's 5 squared, and C is my hypotenuse, so I'll just leave C there. Now we can solve this problem. 4 squared is 16, 5 squared is 25, and C squared remains as C squared. Now we get 16 plus 25 is 41 equals C squared. Now to find out what C is, you take the square root of both sides. And technically this would be the plus or minus square root of 41. But we know that when we simplify this and we get C equals, since we're talking about a distance, it has to be a positive distance. You can't have a negative distance for a length. So we know that C has to equal the square root of 41. Now that's simplified, or you could type it into your calculator and find that C equals approximately 6.403. Now let's look at 2 more applications. Now we're going to find the lengths of the legs of the triangle shown. Let's begin with the yellow triangle. If our right angle is in this bottom left-hand corner, that means the hypotenuse must be this side here, and that length is 12. So again, if I use the Pythagorean theorem, a squared plus b squared equals c squared, I'm going to plug in 10 for my length of A, since that's one of my legs, and B is my other leg, so that will stay there. But in for C, I'm going to plug in 12, because that is the length of my hypotenuse. Now I'm going to solve this. 100 plus b squared equals 144. And this time, like any other problem that I'm solving, I need to isolate that variable that's squared. B squared equals 44. And now to find out what the square root of that is, I square root both sides. So B has to equal the square root of 44, which we know from earlier that can be simplified to 2 root 11. Because that would be square root of 4 times square root of 11. And if we wanted to get a decimal approximation of that, you could say that b would roughly equal 6.633. For our final example, we'll look at this orange triangle. And for the orange triangle, we notice that though it's slanted, our right angle is in this corner here, which means that our hypotenuse is again 12. So we'll use the Pythagorean theorem, a squared plus b squared equals c squared. We'll plug our legs in. A is one of my legs. Another leg that I have is the square root of 19, so that gets squared. And my hypotenuse is 12, so that gets squared. So now I solve this problem. A squared plus 19, because the squared and the square root are opposite operations, equals 144. I subtract 19 from each side and get a squared equals 125. And when I take the square root of both sides, I find that a is equal to the square root of 125, or when you simplify that, that's the square root of 25 times the square root of 3. So that'd be 5 root 3. 5 square root of 3. And again, the decimal approximation of that, if we used our calculator, would be a is roughly equal to 11.180.